Finally, Unity has released a package that makes creating node-based systems easy. Today, we're going to install, use, and extend the behavior package so that you can get a feel for what you can do with it, not just for behavior trees, but potentially for any kind of node-based logic. We're not going to be looking at Muse or any generative AI. Instead, we're going to look at how we can use it ourselves with the actions, logical flows, and event channels that exist, and how we can make our own by understanding how to use the graph and how to extend the code. Let's get into it. Let's start by installing the package. If you head over to the Unity registry in the package manager, just search for behavior. As of today, the latest version is 1.0.2. As soon as that's done, I'm also going to bring in both of the sample packages. They have some interesting examples and some extra predefined nodes you can use in your graphs. And this is done, let's quickly hop over to the dependencies tab. I just want to point out that there are quite a few dependencies here, but nothing too surprising. Some of these packages are used by nodes, some for serialization, and so on. In Unity speak, a behavior graph is the same thing as a behavior tree. You can make a new one by navigating to Create, Behavior, and select Behavior Graph. If you double-click the new asset that was created, it'll open up the graph window here, which you can dock anywhere that you want. Personally, I found it easier just to put it over to the side instead of docking it because it takes up a fair amount of space. However, you can zoom in or out and you can move these boxes around, collapse them down and whatnot, the same as you would with shader graph. So let's start by making our first node. If I right-click here, I'm going to get a little context menu and I'm going to get two options. The first one, Add, is going to let you use any of the nodes that already exist. Main types of nodes are action, events, and flow. By far, action nodes are the ones you're going to create the most, and there are a lot of predefined ones. You can see some are defined at the root level here, and then there's quite a few subsections too, so you can categorize these nodes any way that you want. Let's take a look at one of those now. I'm going to select the navigation subsection. And in there's one called Patrol, which is a really easy way to get your agent moving between different waypoints. Selecting that will give us a new node on the graph, and I can connect it together to my onStart node by dragging a line from onStart down to the new node. If you're like me, you can't stand these crooked lines, just right-click on the parent node, go down to Align, and you have a few options there. So you'll notice there's a few empty boxes on this new node where we can actually assign some references. This is for dragging in references from your Blackboard, which is up in the top left corner. You'll see it only starts with one value, which is self. That's the game object that this behavior graph is attached to. Let's drag that reference down into the box, and then we're going to have to create a new variable that's going to have a reference to our waypoints. For that, I'm going to create a new list, and it's going to be of type gameObject. I'll just call it waypoints and drag that reference down into the box. Seems simple, doesn't it? There is a little bit more work to do though. If I select my enemy in the hierarchy, I'm just going to collapse up all these boxes here and give myself some room. All you have to do to connect up this graph to the enemy is drag and drop it, and you'll get a new component called behavior agent. It already has a reference to this behavior graph, and all of my Blackboard values are actually exposed here. The self property is already populated with this game object. I've already created all my waypoints as empty game objects. I'm going to lock the inspector and drag each of them in here to populate that list. One thing that's really easy to miss is that both the Blackboard and the inspector can actually be expanded, and they have a little scroll bar that's very lightly colored, so it's easy to miss some of these other variables. Now, all of your nodes can have variables that are not Blackboard variables, but they're variables just for that node. They're serialized, and you can change the values of them here. So for example, the default navigation speed here is 0. So if you don't change this value, your agent's not going to go anywhere. I think actually this particular node, the Patrol node, is a great example you can use for when you're making your own nodes. And we're going to look at the code for this in just a minute. For now, let's make sure it's working by pressing play. I think what I'll do is come back to scene view here and give us a more aerial view. You can see I've given all the waypoints little blue gizmos. The agent's going to head all the way over to the first one. I mean, it just goes in sequence, right? So head to the first one, has a little pause as was set in the inspector, and then I'll move on to the next one. Back in our behavior graph, you can turn on debugging for any given agent. Just up in the top left, click that button, select the agent you want. It'll start showing you symbols on every node that'll show you success, failure, or waiting. That'll look a lot more exciting once we have more nodes in the graph. So our agent has now completed one round of the waypoints and started on round 2. I think what we should do next is have a look at this actual code for this node. And you can look at code for any node by selecting the node here in the behavior graph and then clicking on Inspect Script. The first thing to notice here is that there are several attributes. The top ones, serializable and generate property bag, are used to save the state of your behavior graph so that you can load it back from the same state the next time you start your game. If you do want to be able to load back in your node state when you're loading a saved game, for example, you'll need to follow 5 steps that are outlined in this page of the documentation under Custom Nodes. Now, just below those 2 attributes, we've got another one here called node description, and this is what's showing all that metadata in the inspector of the behavior graph. The 4th parameter in there is called story, and that's what exposes variables that you can drag and drop. Notice that agent and waypoints are both in square brackets, and if you look just a little bit down into the class definition, the first 2 member variables are Blackboard variables, also named agent and waypoints. There's some custom editor tooling that's going to make sure that those variables are exposed for you in the node in the behavior graph and that these member variables get populated with the correct references. These other member variables here are the ones that get exposed in your inspector. So speed, the waypoint wait time, and so on. Those are all things that we could set in that inspector window inside the behavior graph. Notice that here we're setting an animator speed param string to a value of speed magnitude. Now, this is because this particular node wants to access things in the animator controller. And if you don't have a parameter named speed magnitude here that you're using in a blend tree or whatever, then it's not going to be able to know what to do, and you're going to get an error in the console. So make sure that the values you're using inside of your behavior graph match things in other components that you need them to, especially when it comes to string values like this. Just going to page down here so we can see the bottom half of this file. So underneath all of our serialized references that we're using in the inspector of the Blackboard graph, you can see that there are 3 private fields here. They are not serialized. They're just populated at runtime, things that we need for the node to function, but we're not going to save any of that information. Below that, we've got several private variables that are annotated with create property. Now, this is used for serialization. Those values would be kept as part of the serialization mechanism for these objects. Below that, you're going to see some familiar culprits if you're familiar with behavior trees: on start, on update, on end. These are all virtual methods that we can override and have any custom functionality that you want. So if we open up the on start, for example, you can just see that it's checking to make sure that we have an agent, we have some waypoints, then it's running that private initialize method, which is just finding the different components and getting references, and then so on. It's just doing population and setup. Similarly, the on update method is just making sure that the agent is moving along to the next waypoint, and on end just make sure that the agent is actually stopped. This patrol action inherits from another class, action. Let's take a look at that. You can see here that action is a small class that inherits from node, and a node is the base class for almost any custom functionality you're going to want to implement. If I search for the keyword virtual in this class, you can see that there are 7 instances of that. The first 3 are the methods that we just looked at: on start, on update, and on end. Then there are 4 other methods that you can use to do different things like reset. We won't get into all those during this video, but if you're building your own custom nodes, it's worth coming in here and having a look at what all your options are. If we come back to the patrol action, what I'm going to do is actually go up to navigate and choose select in. Then I'm going to choose the first option, Explorer. That's going to take me right down to where this file is inside the behavior package. This is a really easy way to start browsing through the package and see what all's available to you and what you can use as examples. You can see there's all kinds of actions here, composites, joins that are already defined. And if we scroll down a little bit, you'll see a lot of those base classes that they inherit from, such as join, node, action, and so on. We're going to make our own custom action here in a little bit. For now, let's go back to Unity. I want to take a look at making a sequence next. So I'm going to create a new action. Down at the bottom, there's one called talk. This came in with the samples project. Talk is an action that will display some text in world space above your agent's head for a certain amount of time. Now, instead of dragging in my reference this time, I'm just going to click the little link icon and grab the reference that I want. And then I'm just going to enter some text into this string field. You can see up in the inspector there that my values are getting populated as I select them here in the node. Now, if I grab this node and I drag it above the other one, you can see this black border forming. That's going to be a sequence where everything inside of that black outline is going to execute one after the other. Let's hit play and try that out. I'll just switch over to the game view tab so we got a clearer visual here. When I press play, we see the text above the agent's head, lasts for just 2 seconds, and then the agent goes off and starts doing their thing. This particular node is actually instancing a prefab of a text mesh component. You can tweak these values if you want, or you can replace it with something totally different. So even though that node is a little bit trivial, it does have some logic inside of it that's figuring out where exactly in world space to position the text and everything. It's another good example of code you can look at when you're starting to create your own custom actions. So why don't we take a look at the next kind of node that's fairly important, which is the flow. In the flow category, we have all the nodes that are going to handle the different logical flow operations through your behavior tree. Now, there's all kinds of things in here. There's conditionals and other kinds of sequences. We're going to take a look at some of these, and of course, you can make your own. Let's start with random. I'm going to select the arrow going from on start to my sequence and press delete. And then instead, I'm going to drag a new arrow to random and then an arrow from random into my sequence. Now, of course, that already looks sloppy. So let's go down to align and align all children. That'll give us a nice graph again. Okay, so random is going to let us choose between multiple sequences to execute. So right now we only have one. Let's make one more. Let's just create a new action here. How about first of all, let's just make another navigation one. Let's make a navigation one that actually navigates to a location. So we'll keep this one pretty simple. We can say that the agent is going to navigate to 000 in the world. So we'll pick self as the agent, and yeah, we don't really have to change anything else. You can actually assign a vector3 reference from your Blackboard if you wanted to. In fact, why don't we do that? If I click on the link icon beside the XYZ, it's going to give me the option to create a new vector3. You can see up in the Blackboard there, I have a new entry. I'm just going to call this home. Now, I'll just leave it at 000 for now, but we could set this to a value in the inspector. So now I've got one node made. Let's turn this actually into a sequence. I'll have another talk node just to keep things simple. We can have the agent say something like, I'm going home. So now we can put those two nodes together into their own sequence. And from the random node, I can drag another arrow. So now we have two random choices from this branch. And again, I can right click on any of the parent nodes here and do an alignment to get them looking a little bit nicer. Now let's go back and have a look at the inspector for the enemy now, because just like the waypoints, any variables that you put into the Blackboard are going to be exposed on your agent. So you can see now that I've got a home variable there and I can plug in whatever values I want. So what I'm going to do is actually just put in something that's very close to where the agent is right now. And we'll call that the home point. Notice that beside waypoints and beside home, we see override in brackets. That's because we're going to be using the values set in the inspector here and not the values set in the Blackboard inside the behavior graph. So let's hit play and see what happens. First choice says he's going home. So he moves off not too far away, and then he chose the other branch. So he's off to check all the waypoints. And then when he's done that, there'll be another random choice. He might do the waypoints again, or might try and go home. But now I want to take a look at another kind of node, which is the events. Now, events are very interesting. And if you're familiar with event channels using scriptable objects, this will be nothing new for you. Notice that on start, you can see in the inspector is labeled as an event. And you can actually have multiple on start nodes in any graph. There are 4 main types here, and when you create a new one, it's going to prompt you for the scriptable object channel that you want to use. So let's pick one of these here. Let's start with a send event message one. So now we could get a reference to a channel that we've already made, but I don't have one yet, so there's nothing to choose from. Let's go up to the Blackboard panel and click on the plus icon, and we can create a new event channel for use in this Blackboard. Under events, you're going to see an option here to create a new event channel. Selecting that will give us a new little modal window. You can choose to put it under a category or, just leave it at the root level, and then you give it whatever name you want. So here, why don't we call this one enemy detected, and we'll use this for broadcasting messages if we've encountered an enemy anywhere. So click next. Now you can describe the message that you're going to broadcast into the channel. So it has a suggestion here, actually, agent has spotted enemy. Let's just use that. Now notice that it's taking every individual word that I've typed. It's going to give me the option if I want to make that a reference to something in the game, or if it's just a text part of the message. So I think for this message, I'll make agent a reference to a game object, and I'm also going to make enemy a reference to another game object. So now you can see up above the modal, it's giving me the samples of what my nodes will look like and how I'll be able to use them when I actually create a new one. If I click this blue Create button, it's going to bring me up a window where I can select where to save this particular file. So I can just navigate to wherever I want to save this scriptable object and click Save. Now it takes a minute because it's actually going to create that asset in your project. So it's going to sit there silently for a couple seconds, and then suddenly you'll get this pop-up that says it's reloading the domain because there's a new asset in your project now. Okay, when that's finished up, we can start putting this to use. So now I've got my node here. We need to select the channel that I want to send onto. So you can see it's there in the menu now. I'll just choose that. And now you can see I've got the prompts that are available to me in that message channel. So let's add self as the agent, and let's actually create a new Blackboard variable here for the target. So I'll call it target, type game object, expand this a little bit too so we can see the whole Blackboard. There we go. So I'll drag that field in, and now we're ready to use it. But how should we use it? Let's see. How about we get rid of the random node? I'll just delete it, and I'm going to add a new type of flow. And I think this time we can do a parallel execution. So here you have a few options. So I'm going to choose the first one. I want to run both sequences in parallel. So what I'll do is drag an arrow down from on start. And I want to set this up so that the second branch doesn't do anything until it receives an event on the channel that will be published by the first branch. So I'm going to move the patrol one over into the second one. We're not going to start patrolling until we've gotten an event. Then I'm going to add our send event as the last element in our first sequence. Next, let's simplify up the second sequence. We don't really need this talk one anymore. And let's get rid of the navigate to home. So we're down to just one element here, but let's add another one. Under events, let's select wait for event. So wait for event is, going to be kind of the opposite of our send one. So let's pick the channel again. Here we want to listen for the exact message that we published in the other branch, which was wait for self has spotted target. So as soon as we have those exact matches, we'll start executing the other branch, which is all I'm really going to do is patrol along the waypoints. So let's clean this up a little bit. And I think actually the easiest way to verify this one is to turn on debugging again for the enemy. Let's select the first talk node. I'm going to extend the duration to 4 seconds, and let's just watch it in this view. So you can see now as I hit play, we're going to have a 4-second wait on the first one. Then we publish the event. Immediately, the second branch picks up that event and starts running the patrol. Now, there's quite a few scenarios where events might help you out. The first and probably most obvious one is here in your behavior graph, you can have multiple on-start methods. And so you might want to just start one of those when an event is published, or you might want to publish an event where multiple branches inside of your graph are picking it up and starting to execute different branches of logic. So why don't we do something that's a little bit less vanilla? How about we make a custom action of our own? I've done a little bit of setup here. I've added a skeleton boss character here, and he has a tag of targets. And I've brought in our sensor from last week's video about utility AI, and I've added it to my enemy agent here. The agent is going to be looking for targets that have that tag targets on them, and I've set the sensor range to 10. So making a custom node is actually really easy, and it's not going to take long at all. If we come back in here and we select create new, you can create one of the different types. I'll select action, and I'm going to give this a custom name. Let's call it detect targets. You can put it under a category if you want. I'm going to leave this at the root level, I think. Now, just like when we were making an event channel, here we get to put in some text. Any of these words can become references to variables on our Blackboard. So let's say agent detects target, where I make agent and target game object references from the Blackboard. By doing this, we're going to have references to those Blackboard fields inside of our script, and we can read and write to them. So just like saving our channel from before, we have to save our new script somewhere. So you just pick a location and click save. When that's all done, it should automatically open up in your IDE. And you can see it's actually fairly straightforward. There's not a lot going on here. You can see we've got our onStart, onUpdate, and onEnd methods already. And you can see as well our node description has our little story in it. And we've got references to the agent and the target. And beyond that, you can start adding your own custom code. You might want a reference to your NavMesh agent. Here, I definitely want a reference to my sensor. And in Start, you can get references to those things from your agent. If you need to reference things from the Blackboard, use agent.value, for example, or you would use target.value. Let's scroll down a little bit here. So since we're using a sensor script that we wrote last week, all we have to do here is say sensor, get closest target. Let's pass in the tag that we're looking for. We can say if the target is null, then let's just return a status of running because we haven't found anything yet. If we did find something, let's assign that into target.value. Pass in the reference to that game object, and then we return success. Back here in the behavior graph, let's make sure that we have our variables assigned into this new custom action. Let's drag it in there as the second operation in the first sequence. So we're not going to do anything until we return success from our custom action. After that, we'll publish the event that we have a target. That'll kick off the logic in the second branch. I'm not going to do anything special with that right now, but you might want to start attacking the player or run away or execute some other logic. So let's take a look in scene view here now. If I press play, you can kind of see the sensor range of my AI agent. It's quite big, but the enemy, my skeleton boss, he's not close enough to my AI agent. So what I'll do is actually just select him and drag him within range. And you can see immediately the event gets fired, the second sequence starts playing, and the AI agent starts going through his patrol route. So even though these examples so far have been fairly trivial, it should be pretty easy to see how you can extend this system to do just about anything that you want. And it doesn't have to be just behavior trees. This would work for any node-based system. Now, one more thing I want to point out, if we come up to the Blackboard, if we right-click on any of these properties in the Blackboard, check this out at the bottom. There's two toggles here. One is to actually expose a variable, which means that you can see it in the inspector. The other one is to make it shared, which actually marks it as a globally shared variable. You can use it across different instances of this behavior graph. So if you have multiple behavior graphs that need to use the same data, you would use that option. And another thing worth pointing out here is that while we have a Blackboard here that's local to this graph, you can create other Blackboards outside of here and reference them within this graph as well. So you can have multiple Blackboards that are shared across multiple graphs. So positives of this tool, I think, building these visual tools to represent node-based systems in Unity has always been a big pain. And I think that this tool does a lot to solve that. It's all built with UI Toolkit. For those of you who are interested in that, it's worth having a look at the code. There's also some very interesting serialization code in here that we're going to have to look at another day. So that's where I'm going to wrap it up for now. Thanks everybody for watching. Don't forget to like, subscribe, join the Discord if you haven't yet. I think I'll put a few AI related videos up on the screen for those that are interested. Maybe I'll see you there.